So hello guys, welcome to the part 2 of the binomial coefficient. This is Utkal from IIT Delhi, right? So in the part 2, we'll talk about properties of binomial coefficients. Properties of binomial coefficients, right? Yeah, let's start the video, right? Again, I mean, these are very introductory video where I'm not, helping you solve many questions, right? For that, you can personally contact me to get the depth knowledge of any chapter I'll teach here, right? So let's have any example of an expression of 1 plus x to the power n. Now, pause the video, give me the general expression which I taught you in the previous class, right? I'm writing it right now. C0 plus C1x plus C2x squared plus C3x cubed plus dot 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 Cn x to the power n, because the index or the power here is n. Now, convert it to the summation formula. Summation r equals to from 0 to n, ncr x to the power r. Very good, right? Where n is equals to, or n belongs to natural numbers, right? Where C0, C1, C2, Cn are, there is second word also, combinatorial or binomial coefficient, or combinatorial or binomial coefficient. This is a different name or the second name, nothing rocket science here, right? Binomial coefficient. Okay, now let's come to the properties. What if I ask you the sum of all the binomial coefficients? Now, how would you derive it? Right? Pause the video, think about it, just think about it, right? I'm telling it right now. Don't do anything, just substitute x equals to 1 here. If you substitute x equals to 1, what will be the left equation with you? It will be nothing but C0 plus C1 plus C2 plus C3 plus dot 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 Cn, which is nothing but sum of all the coefficients, right? So let's put x equals to 1. So if you put x equals to 1, both the sides of the equation, it will be 1 plus 1 to the power n equals to C0 plus C1 plus C2 plus C3 plus C4 plus dot 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 Cn. It is nothing but 2 to the power n, right? So we got our answer. Sum of all the binomial coefficient is nothing but 2 to the power n. Okay. Now, if we put x equals to minus 1, right? If x equals to minus 1, what will we get? You can pause the video and give me the answer. It will be C0 minus C1 plus C2 minus C3 plus C4 minus C5 dot 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 Cn. Why? Right? Because if it is x squared, the first term would be, or the sign in front of the coefficient will be positive. If x to the power it is odd, that is 1 or 3 or 5 or 7, the sign in front of the coefficient would be negative, right? It is C0 minus C1 plus C2 minus C3 plus C4 minus C5 dot 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 Cn. What will be the answer? It will be 0. Why 0? Because it is 1 plus x to the power n, right? If we put x equals to minus 1, it will be 1 minus 1 to the power n, that is 0 to the power n, which is 0, right? It is equals to 0. That is summation r from 0 to n minus 1 to the power r n c r equals to always 0, right? Now, third property, sum of the binomial coefficients at odd positions is equal to the sum of binomial coefficients at even position, right? And each is equal to half of the total sum of all the coefficients, right? So which was the sum of all the coefficients was 2 to the power n. And what is half of 2 to the power n? Nothing but 2 to the power n minus 1. So I'm saying the sum of all the binomial coefficient at odd position is equal to the sum of binomial coefficient at even position. That is C0 plus C2 plus C4 plus dot 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 endless equals to C1 plus C3 plus C5 plus dot 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 equals to the power n minus 1. Okay, I can prove all of it, but in the private class, because here I have a time constraint to explain things to you. Next property, NCR plus NCR minus 1 equals to N plus 1 CR. Again, we can prove this, but yeah, you have to personally contact me for this, where I would have enough time to teach you, right? All of the proofs. The other formula is NCR over NCR minus 1 equals to N minus R plus 1 over R. Again, a formula. Sixth property, NCR equals to N by R, N minus 1 CR minus 1 equals to N by R into N minus 1 into R over R minus 1 into N minus 2 CR minus 2. It can go on and go on, dot, 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 equals to, equals to, can go on into any terms. If I generally write any term, N minus 1 into N minus 2 into dot 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 N minus R plus 1, right, over R minus 1, sorry, R times R minus 1, R minus 2, dot dot dot, ending at 1, right? Now the next property is, that is the seventh one, NCR can be also written as R plus 1 over N plus 1 multiplied by N plus 1 C R plus 1, right? So here I have written all the properties. We can prove every one of them. The proofs are very easy, right? It's not a rocket science, but yeah, you can personally contact me anywhere in Urban Pro, right? In my profile. I think that was it for the next part of binomial theorem, where we discussed about properties of binomial coefficients, right? Thank you so much, guys.